Hello everyone and welcome to finally another video where today I would like to talk about the now already 2 weeks old video on gravity by Eric Dubay because I've heard it is very funny. Now keep in mind that Eric Dubay is one of the oldest and strongest in the sense of most followed flat earthers, which makes this portrayal of his understanding of gravity even sadder. And it's on 1.25 as is customary, as you know. I mean, it's really not, but gladly, and I'm sure it's genuine calculations at the edge of what we understand about gravity. So, full application of relativistic physics. Small side note: if it was a full application of state-of-the-art relativistic physics, I would not be here talking about it because I don't know much about current state-of-the-art relativistics. I've done my entry into general relativity, so and that's it. I'm not a GR researcher or anything. Jeez. And exactly. Now the thing is here already. This graph here is more correct than you will be later. Notice how the r, so the distance of the two, goes from the center of this of those spheres. Really, it should be from the center of mass from one to the other sphere, and not just to the edges. Right. This is an important thing that he will make mistakes on later during the rest of the video. And already, the fact that this is the graphic that you put on here, this is the sketch that you put on here, and it's not typeset properly using points, lowercase points as a multiplication sign in a resolution that is horrible, really, I already speaks volumes, really. Yeah, we know. To very much to his credit, he got this number wrong and corrected it both in the comments as a pinned commentary and up here in the corrections. So he actually, credit where it's due. That's not something that happens a lot with flat earthers. He corrected himself, and rightfully so. And now he's already the problem. If you were to stand 10 meters away from the One World Trade Center, the way he's calculating it is as if you stood 10 meters away from its center of mass, which would not be possible because I don't think there is any place in the One World Trade Center, correct me if I'm wrong, that has just 10 meters of distance to its outer wall. So already you cannot apply this here because, as we'll see later, the the universal law of gravitational attraction specifically applies outside of the object. If you're inside of the object that you would like to calculate gravity for, you actually need to change a lot of things quite significantly. Now, obviously, since he's got his numbers wrong, this conclusion is also wrong by a factor of 1,000, right? So, And now keep in mind that this is too high by a factor of 1,000, and you reach the conclusion that it should not matter. Big surprise. Yeah, and at 1 meters, it would be even more pronounced. You are inside the object. If you're 1 meter away from its center of mass, you're inside the object. If you're 1 meter away from the wall, well, you would need to know how far away you are from its center of mass. And this is the mistake he makes, and he makes this mistake again with a mountain. Not realizing, and this is what baffles me so much, right? I think we can stop this video here. It's just that, and and this and that's essentially the same thing that we hear from flat earthers that we've heard for the last 20 years or so, or 10 years or so. So I'm really not going to cover that. There are plenty of experiments, you just don't accept them as such. For example, where I am, my university has even conducted one of the most precise Cavendish type experiments to date, as far as I'm aware. And I can link the paper, but it is quite complicated, and that's the thing, right? You don't even understand the basics. You're not. MC Toon sometimes says that you're not tall enough to ride, and that is correct. You in more than 10 years, I think more than 10 years, that Eric Dubay has made these videos. He does not realize that the R is the distance between the center of masses. I am baffled, truly baffled, how this could be the case. No less, I've made a short presentation because I always want my videos to contain something for everyday people to learn, right? And so this is the I've made similar calculations. If I was outside at the outside wall, assuming that I'm like 300 meters away, my attraction would be completely negligible when compared to the one world when compared to gravity. And the interesting thing about that is, he says, but surely it would be measurable. I'm sure if you had a completely freestanding, without any other buildings in the surroundings, a one world trade center, and you went close enough, you could possibly measure some sort of effect on gravimeters. But other than that, yeah, no, not in a city. Certainly not in a city. And so that's the thing, really. You have the center of mass, and if you're standing here, if you're for some reason a yellow rectangle now, in which case please consult a doctor. The gravitational force of attraction will be strongest towards the base, a little bit less towards the middle, and very weak on top. So really, you would need to slice this building up into however many slices you want, a lot of them, and do a numerical calculation. I'm not sure if there is a analytical approach to that. I'm not a theorist, so I would do it numerically. You would need to slice the One World Trade Center up, assuming that it has uniform density, which most likely won't. And then you would need to calculate the gravitational attraction to each of these and add all of these vectors up to get a total amount of traction that you will have. So this would be rather elaborative. I thought about doing that for the purposes of this video, but unfortunately I have a lot of things to do. However, if you're inside the building, this is the interesting part. If you're, let's say, on like 1/3 up, assuming uniform density, you would of course be pulled up more by the mass that is above you than you would be pulled down by the mass that is below you, excluding gravity, of course, talking only about the tower itself. But now you cannot use the universal force of gravitational, universal law of gravitational attraction, or at least in this formulation, not anymore, because you're inside. The strictly speaking, R is not freely choosable. R is only specified for R bigger than the radius of what you're talking about. But for example, if you were to do this with the Earth and you drilled a tunnel through Earth and you were a fourth of the way in, how much gravity would be towards which direction, which is actually a very, very common example that you give physics in the bachelor's degree. We had that in our first semester of physics. Actually, this was one of the problems that we had to solve in the entry to classical mechanics, or the equivalent thereof. But when you're in a shell, things get actually quite complicated. Imagine if Earth was hollow. Exactly, I have turned into a hollow earther in my break. No, if Earth was hollow, things would become quite complicated. If you're outside of this shell, the normal law of gravitational attraction would apply. If you're inside the shell, things would get complicated very quickly, as you can see here. If you're curious about what all of this is, please consult the Wikipedia page. But inside the shell, things get a lot more difficult. You need to, the point that I would like to make here is, this R here is only works if the small r is bigger than the big R, in case where the big R is the radius of whatever you're talking about. That's really only where the universal law of gravitational attraction works in this formulation. The inside the shell thing, by the way, is also from Newton. Newton considered that he but when this law is repeated, it's not repeated in its precise mathematical notation, which is completely understandable. And the serious question to end this short little video on is, how did you not know that by now? Jeez, you've been doing this for a decade. If I were doing something for a decade and I'd still not be capable of doing literally one of the first things you do when you're introduced to gravity on a proper level, it's probably stop doing it. There is no point in that anymore, because obviously I suck at it. So a small little thought for you there. And to everyone else, I hope you learned something, and I hope you enjoyed watching this video. If you did, maybe consider leaving a like. And if you enjoyed it a lot, I would be extremely happy if you subscribe. And I hope to see you a little more sooner again. But oh my god, I need to do paperwork beyond belief. I will submit the paper within the next 7 days. I need to apply for a PhD. I need to write my second master's thesis. I need to do a conference, 2 conferences. Actually, I will. Oh god, yeah. I will see you in the next video. Goodbye.